Right, good morning, upper fives. We're just finishing off Argand diagrams, modulus argument, trig, etc. I know it's been a bit of a tough week, but the first session of next week is a double free, so you can catch up, consolidate, have a nap, do whatever you need to do in that session. Helping us today is Jody. Thank you, Jody. And Ewanumi. And Rosa Potenza. Right. So thank you for coming in and helping us out. It is much appreciated. You should be working with the worksheet for session 11. Okay, worksheet for session 11. And yeah, let's go to that right now. Okay. Righty. So let's just make sure we've got a bit of the trig figured out. As I said, trig, you're going to do quite a lot in core. You'll consolidate this, but as I say, perhaps it's a bit of a head start for you. Okay, and it'll help you get to grips with what a lot of people find a difficult section in core. Right. So with all of these ones, okay, you should have tried the worksheet already, and you should just really be marking. So I'm going to go fairly quickly. So the first question is, we're working in trig. So remember, our axes are x and y. He has an x coordinate, he has a y coordinate. First question is determine your radius. Your radius is the distance from the origin to the point of concern. So to figure out r, we're going to always use r squared is equal to x squared plus y squared. Remember, any deliberate areas that are spotted get a chocolate. Okay, so therefore r squared is going to be 5 squared plus 4 squared. So r squared is equal to 25 plus 16, which is equal to 41. So therefore r is equal to the square root of 41. And if you enter that into your calculator, we can get to something called simplest third form, but that's already in simplest third form, so it just won't change. Okay, so r is equal to root 41. If you had something like root 20, your calculator would automatically convert it to 2 root 5, and you'd leave it in that form over there. So now I know my radius is root 41. Okay, so I know that for this angle theta, okay, I can use ratios of x is 5, y coordinate is 4, radius is root 41. And once I have that information for an angle, okay, remember those ratios stay fixed, so I can work out all three of the trig ratios. So in question 2, what is sine of theta? Remember, shade your rear, so sine is equal to the ratio of the y coordinates over the radius for that angle, and if the y coordinate is equal to 4, then the radius would be root 41. So your answer is 4 over root 31. That's sine theta. For cos theta, we're going to have cos theta. Let's go up a bit. Cos theta is equal to the x coordinate over the radius. Shade your rear because x rays, and the x coordinate is equal to 5, and the radius is root 41. So it's 5 over root 41. And then for the last part of 2, tan theta is the ratio of the y coordinates over the x coordinates. Okay, and the y coordinate is 4, and the x coordinate is 5. Right, so that's all of 2 done. Okay, there was 1. Okay, there's 2. Right, and then question 3, evaluate theta. I could use any of these 3 trig functions. If I use tan, I'm going to use the fact that tan theta is equal to 4 over 5. It's useful to work with tan because if you've made a mistake somehow finding r, tan doesn't get affected by that. Okay, and so you're going to go to find the angle. You're going to go shift tan to the negative 1 of 4 over 5. And we're going to get to 2 decimal places. Theta is an angle, so the size of that angle to produce those ratios must be 38,66 degrees. Okay, right. That is that page done. Okay, hope you got them all right. Bit of a waste of time if you're just listening, guys. Really got to try things yourself first. Okay. So, Ewanumi, in the next one, it says, we're going back, we discussed this the other day, representing complex numbers as Argand diagrams. So I've got z is equal to 7 plus 2i. So first question says, given z is equal to the complex number 7 plus 2i, represent z as an Argand diagram. Okay, so what's the real part of z is 7, and the imaginary part of z is 2. So on the complex plane or the Argand plane, there's our real part, there's our imaginary part. So what do I do, everyone know me? Good, you go 7 across, it's just estimates. So let's make 7 about over there, let's make 2 over there. So this means the point we're going to plot is 7, 2. Okay, the real part goes first, then the imaginary part. So 7, 2 is roughly over here. So this is z 7, 2. You can label it like that, or you can say z is equal to 7 plus 2i. Same thing. Okay, right. And then draw our Argand diagram. Lost my ruler. Here it is over here. Z is equal to 7 plus 2i. We're going to join that up. Okay, right. So there's z. Okay, I drew in the line. You could have just left it as a point, but I drew in the line because we're going to have to do next. So Rosa, in the next one, it said, okay, so that's part 1 done. There's our Argand diagram. Part 2, determine the modulus and argument of z. So remember, the modulus of z in this notation is equivalent to the radius in trig, and the notation is mod absolute value of z mod z, right? And mod z, just like with r squared, is x squared plus y squared, would be equal to the real part squared, which is 7 squared plus 2 squared. So that's mod z squared. So mod z would be equal to the square root of 49 plus 4 is 53. Okay, so mod z, the modulus of z, don't have to write it in words, would be equal to, let's just check, z squared is 7 squared plus 4 squared, 49 plus 4 is 53. Mod z is root 53. You can just write it, I would just write it like that. So mod z is equal to root 53. Okay. Make sure that's in focus. Okay. Right. Then the next one, okay, go figure out the argument of z. So if we let the argument of z be equal to theta, you can write it down, but if you fill it in there, then you're telling the marker that that's what you're letting the argument of z be. Okay. So to find that angle, well, let's use a trig ratio, and the one that's we can use, which is easiest, is what links up x and y. Okay, because x raised tan your exterior, so you know that tan of an angle, where the angle is measured in an anti-clockwise direction from the positive real plane, tan of theta is going to be equal to y over x. So tan theta is equal to 2 over 7. So to find the angle, you're going to go shift tan to the negative 1 of 2 over 7, or 2 divided by 7. And Rosa, what did you get? Yes, you are indeed correct. Theta is 15,95 degrees. Okay, so there's your argument. Your argument is 15,95 degrees. Okay, and mod z is equal to root 53. Okay, there are your two answers. 15,93, mod z is root 53. 15,95, sorry, and mod z is root 53. Okay. Righty, hope that all made sense. Okay. Right. And check. Okay. Right. So the next question says, given z is equal to 3 plus 4i, 3 plus I over 4 minus I. Represent z on the complex plane. In other words, that's the same thing as saying represent z as an Argand diagram or an Argand plane. Argand was a French mathematician. Okay. Right. So if I'm drawing something on the complex plane, okay, my axes are going to be the real axes and the imaginary axes. Okay. But at the moment, the problem is 3 plus I over 4 minus I is not in the form. I've got to get it in the form z is equal to a plus bi. In other words, I have to divide out and simplify. Okay, so we're going to have to do that division before I can represent z on the complex plane. So Jody, if I have z 3 plus I, if I'm dividing 3 plus I over 4 minus I, what do I have to do? You're a Liverpool supporter, of course you got it right. You're going to times the top and bottom by the conjugate of the denominator, which is 4 plus I. Okay, and if you go simplify that, you're going to get, okay, remember the denominator, once you're timesing by the conjugate, the denominator should always be a constant. Okay, so if I do the top, I'm going to get 12 using FOIL plus 3I plus 4I is 7I plus I squared. 12 plus 3I plus 4I, 7I plus I squared. And in the denominator, you're going to get 16 minus I squared. So remember, what's the key idea here? Good, it's that I squared is equal to negative 1. Okay, so you've got I squared is equal to negative 1. You can skip out steps. So it's going to be 12. Okay, I'm just going to write it down. Plus 7I plus negative 1 and 16 minus negative 1. Okay, which is going to give us, I would definitely skip out steps. 12 minus 1 is 11. So you get 11 plus 7I. And here you get 16 plus 1, which is 17. So it's 11 plus 7I over 17. Okay. So this is Z. So the real part of Z, a bit of ugly numbers, real part of Z, I could write this, remember, as 11 over 17 plus 7I over 17. That's Z. So Z is equal to 11 over 17 plus 7I over 17. So the real part of Z is equal to 11 over 17. And the imaginary part of Z is equal to 7 over 17. Okay. So those, the points you're going to plot then, because you're asked to represent Z on the complex plane, is 11 over 17, 7 over 17. So 11 over, think of it as being 11 and 7. Okay, so 11 is more across than it is up, roughly. Please don't go spend hours measuring. So 11 over 17, if that was here, 7 over 17 would be somewhere over there. Okay, so your point, that's Z, which is equal to 11 over 17, 7 over 17, right? And so, or you could write Z is equal to 11 over 17 plus 7I over 17. I generally just write the point over there. Okay, so remember, you're dividing, you multiply the conjugate, that becomes 16 plus 1, which is 17. Top 12 plus 3I plus 7I. I don't want to hand out more chocolates, I'm just checking. I squared is negative 1. So you get 12 minus 1 is 11 plus 7I over 17. Okay, that looks good to me. We're not quite done though, because the next part of the question said, find the modulus and the argument. Okay, so to do that, I'm going to draw in this diagram. It's going to get some ugly numbers, but that's okay. Here's Z. Okay, so if I'm going to go work out, just make sure you can see that. Okay, right, and we're going to have the modulus of Z, I'm going to skip our steps, is going to be the square root of, I'm using the fact that r squared is equal to x squared plus y squared. That's kind of my starting point using Pythagoras. So r is the square root of that. So in other words, Z in this language is going to be equal to the square root of the x coordinate squared, 11 over 17 squared, plus, it's going to be an ugly number, 7 over 17 squared. And that's just a bit of calculator work. So you're going to go the square root of 11 over 17. Okay, Z is equal to 11 over 17 all squared, plus, okay, 7 over 17 all squared. And so Z is going to be equal to root 170 over 17. So that's your modulus of Z. So your modulus of Z, the distance from here to here, is root 170 over 17. Okay, right, and I'm not quite done because the next thing that we need is the argument of Z. So if we draw that in there, we've defined the argument of z as being theta. Okay, that's fine. And then we know that tan theta is the y coordinate over the x coordinate, which is going to be 11 over 17 divided by 7 over 17. 11 over 17 divided by 7 over 17. If I tip and times, I'll end up with tan theta, the 17th will cancel out, is equal to, you did in one step on the calculator, is tan theta is equal to 11 over 7. So to find the angle, you're going to go shift tan to the -1 of 11 over 7. And that gives us an answer of 57,53 degrees. Theta is equal to 57,53 degrees. A lot of you panic when you get horrible numbers, like these things, the third and, okay, weird fractions and thirds and strange numbers. Okay, have a right to exist, just like strange people like Kira have a right to exist. Strange numbers have a right to exist, even if they make our lives slightly unpleasant and difficult. Okay, well done, guys. So that was example 3. I hope there are no errors. Please point them out as they are and claim your chocolate. Okay, so what's left to do? Okay, remember, you can do it today, or you can do it in your first free. Your next session, or first session of next week is a free, so it's up to you when you want to do it. But you're going to have to do exercise 4, page 9, mind-born maths, the whole exercise. Okay, just one thing, it doesn't specify it explicitly in the question. It asks you to find the modulus and the answer and the argument, but please first sketch, your first instruction should be represent Z as an Argand diagram. You can't really work out, I don't think, without diagrams. Okay, even if they don't explicitly ask you to find it, I want you to do that. Then you find the mod and the argument of Z for each question. Okay, and you should really then, just to check you understand what you're talking about, go label your answers. Okay, those answers on your original diagram. All right, guys, thank you very much. Have a great weekend. Arrivederci. Oh, sorry, forgot to thank our guests. Okay, to Jody and Ewanumi and Rosa Patenza. Okay, thank you very much. I hope you all know Rosa from Brooklyn Nine-Nine. She's actually my hero. Right. All right then, guys. Farewell. Goodbye.